Hello, Maurieo. In this video, I'm going to be investigating how to work out areas by double delatures and departures. This is the classic way of working out areas that I was taught when I first was introduced to surveying in the late 60s, early 70s, and this is how I was taught to calculate areas. In those days we only sort of had calculators and the like. So here we are, we have a traverse A, B, C, D and back to A. Now I have first of all initially calculated this traverse out very carefully so that there is no actual adjustment. It's a perfect close, and that was just to make things a little bit easier for me. Now if we then just produce out here and draw in the northings and eastings, or the differences north and difference east around it, we can see that we get this a rectangular shape there. And I've put in here the bearings along here, and from them the northings, so that we can see what each one is and how they're labelled, hopefully, although they are looking a little bit small at this point. So perhaps if I just boost the let's just make things a little bit bigger here so that we can have a bit of a closer, perhaps just a closer look at the diagram here. So here we have A, B, C, D, like so, and this is the northing one, easting one, going from A to B. I was always taught when we did these things that the best way to do them was to always start at the westernmost point and work clockwise around the thing. That made the mathematics of the thing work out with not too many negative numbers. So here we are, we've got our bearing north in the northing and easting of this one, the northing and easting here into E2, N3 and so on and back through there. So you can see that there's quite a little bit of a pattern developing there. Now the other thing that you can also see, as I just perhaps zoom out a little bit now, that we don't say, I'm just trying to position things there. See how we go. Oops, we're going the wrong way there, because here we are, we have our formula. Now what we can see here, that if we want to work out the area of A, B, C, D, we can see that it's equal to, and we join this little dotted line through here as a construction line, it's equal to KBCL plus LCDM, KBCL plus LCDM minus KBA and minus ADM. That we can, from that we can determine that area, and the way to determine that is to use this formula here, which gives us twice the area, and it's N1E1 plus N2 times 2E1 plus E2 and so on, and you can see and you can read it as it's working through there. I've actually got a little bit outside of there. Hopefully you might be able to see that diagram a little better now, and yes, you can that's the formula there. Now if we just we'll just zoom in a little bit, and we'll get down here to our actual calculation here, which what I've done here. These are the bearings and distances, and we just need to move over there a little bit more. These are our bearings and distances here, and we just run them out as we do traditionally in a traverse. I've been using Excel here, so I've put these in as individual values in the cell. That enables me to actually work out, or to get Excel to calculate these values for me here. by just making converting these into radians, and then taking the cosine to get the delta north and the easting to get there. So you might be able to see those formula that I've keyed in up in here for each one of those. So again, it's just the degrees plus minutes divided by 60 plus seconds divided by 3,600, and then I've divided that by 180 and multiplied by pi to get it into radians. That just gets it into radians, and then we've multiplied that by the taken the cosine of that and multiplied by the distance, and then it's the same thing here, same sort of formula, except we use the sine, and that gives us the easting. And so I've gone through and done all of those here, added them up, and they come to 0, which is exactly how I planned it, all part of my cunning plan. So now it resolves to work out the what we call the double departure. And although some people only show this on one side of the equation and work out one side, I was always taught to work out both sides of the equation as in a check. So in this case here, I'm just going to work out on the easting. So what we do is we work out the double departure. Now to do that, we just take the easting, and the first one just goes straight in there. Now this next one here, what we do is we add above, we add that, and then we add that again plus one of those. So just going back here, it's one of those, one of those, one of those. Put that in here, and then we move down to the next one, and again it's one of those plus one of those plus one of those goes in there, and then we move down to the next one, which is one of those, one of those, one of those goes in there, and that should be the exact opposite to that one there. So that when you get down to here, if you've done it right, that number there and that one there should be exactly the same. Now if there is some adjustment, you need to apply the adjustment and then use the adjusted values in here, but I've made sure there's no adjustment just to make this one nice and easy. So let's just go, so you put that one in there first, then you go one of those plus one of those plus one of those, that goes in there. Here, one of those, one of those, one of those in there. And then here, one of those, one of those, one of those in there. And this is what's actually happening here. That's what each value represents. And then you come over here and you just multiply that by that. Okay? And that gives us double the area. So it's that by that, that by that, that by that, that by that. You get down to here, you sum them all up. Now it's negative, but don't worry about that, that doesn't matter. You can't have a negative area, so you just take the absolute value and divide by 2. So that's double the area, and then this here is the actual area here. So I'll just make that bold. So that's our actual area in meters squared here. So that's it in there. All good there. Okay, I might just actually move that and just put that in there. Yep, there you go. And let's just put a little box around that. If you wanted to water. Okay, so there you go. Put a nice little box around it there, and we'll do the same here. I'll just show you how to do that. Format cells. Yeah, nice little box around all that. Okay, that's there. Now, same thing applies over here, except instead of using the easting, you do it with the northing. So it's just one of those, and then in here it's one of those plus one of those plus one of those. Go down here, and then it's next one is down here is one of those plus one of those plus one of those, and that goes in here. And then similarly down here it's one of those plus one of those plus one of those. Now you can see on this side here that because we started at the westernmost edge, as I said and recommended, we get nice positive values in here. It's not quite as nice and tidy over here on the other side, but nonetheless it does work out. And again, that value must equal that value, the negative opposite of that. Okay, and then it's just a matter of multiplying that by the easting. So it's opposite that by the easting, the opposite to what we did on this side, and we should get the same total, exactly the same total. And in this case here, we get a nice positive value. So and divide by 2, of course, to get the area. And there we are. We'll make that bold just to be a little bit of consistency there. So there you are. That's the method. The area by double delatures and departures is how it's explained. One of the traditional old ways of working out areas of fixed, of boundaries and sections like that. I've done many of those, particularly some of the larger 50-sided ones. Some of them could take up to a day to get it all calculated and closed and get the area. Obviously, get each side equal. The two answers the same before the boss would tick it off and let you go home. So there you go.